Okay, so I see about 10 participants. I think there should probably be more. Anyway, welcome to the course IDS 594. This is MLOps, basically operationalizing machine learning models. My name is Teja, and what I'm going to do is this lecture, it's going to be about getting our feet wet about deploying machine learning models. So what I'll do is first introduce the course structure, some of the logistics, and then we'll get into the content of the course. At any point, do ask questions, using chat or using your voice. Okay, so what I'm trying to do is get people oriented towards the resources available for this course. Most of you should have access to Blackboard. So on Blackboard, much of it is about the general information about online teaching and online courses. So the things that will be relevant to us is the link to the syllabus page, and that I've opened it in one of the tabs. The second thing that will be relevant will be the lectures tab, which will have link to the lectures. And I'll it's basically a link to GitHub notebooks. A link to a bunch of notebooks which are hosted on GitHub. The third most important link will be the project upload link. Here's where you will upload your projects. I'm going to talk about the course structure in a minute. And I guess the final link would be the Zoom link. That's where you'll get the access to the meeting information, as well as the recordings will be available there after the lecture automatically. Okay, so let me open the syllabus page. So everybody should be able to access this page. Um, this talks pretty much goes about the details of the logistics of this course. It's a 2-credit course, so it's only going to run till the beginning of March. And some of you or most of you may be wondering, like, what's the content of this course and how is this relevant to the other courses that you've seen in MSBA or MIS programs. So this course is actually a survey course. So it's actually, it keeps changing as a function of new tools and techniques that come up. It's a course that focuses on getting us exposure to deploying machine learning or analytics based artifacts. Okay, so mostly we will be talking about machine learning models, but you can think of even visualizing clusters and so on, which are not prediction models by themselves. Okay, so in that sense, this course complements some of the things that you'll see in IDS 572 or 575, or even 576 that I also teach, which is about deep learning, as well as many other things. So most of the ML techniques or analytics techniques that you've seen, you've been working on them potentially on your own local machines or on remote machines. But most of it has been somewhat offline, right? So the problem statement has been given, maybe a data set has been given, and you use that data set effectively to maybe build a prediction model and show maybe a validation or a test score of how it performs, and then somebody else takes that output and maybe builds it into a service for consumption to end clients, or maybe even for internal consumption in the organization. Okay, so in that sense, what we will try to do is to also learn those ideas, which is how to operationalize ML workflows and in particular models, uh, depending on the business needs. Okay, so different business needs, for example, if it's a startup, will have a different set of tools at disposal to deploy a machine learning model. And if it's a large Fortune 500 company, for example, will have a very, very different way of deploying anything, and also machine learning models. Um, so This course is also a little bit complementary to IDS 561, which is about big data. So in that course, you would have seen technologies like Spark or Hadoop, and many other things like Hive and so on. Here, we will intersect that course a little bit in a couple of lectures, but mostly again in terms of um, running machine learning training in the cloud, as well as being able to make the trained model reachable from the cloud, as in from a machine, so that our clients or some other, like end customers can, use that model in their problem. Like for example, use predictions. Okay, so we will, since it's only a half credit course, we'll only be looking at a few subtopics, select subtopics in this whole machine learning lifecycle, and in particular, there'll be some elements of model management, some elements of model monitoring, and mostly it'll be about deployment, the first few lectures, which is once you build a scikit-learn model or a PyTorch-based model, how do you, make it, accept requests, accept test inputs, and how do you send predictions back, okay? And towards the end of this course, we'll also look at something called A/B testing, which is when you build something new. Okay, you also need to show evidence, data-based evidence, that whatever is the new thing that you built is better than what's existing, right? In the sense that maybe the business, let's say, to be concrete, and we'll have a very concrete example running through the course, which is about recommendation systems. So let's say there's an existing recommendation system in place. It's showing various product recommendations or movie recommendations, and you have analyzed user data, and based on what you think is new user is the right user behavior, you know how to probably recommend better. Okay, so you have the collected data from which you built a model. Now and you built a model, and maybe offline test scores or validation scores are looking good. You still want to convince the stakeholders that your new recommendation engine or recommendation system is better than the existing one. And for that, one of the canonical tools you will go to is A/B testing. Okay, and there are many, and when we touch this part of the course towards the end, we'll look at many commercial vendors who offer such services, as well as we will actually do a minimum working example where we will be able to deploy an A/B testing setup. Okay, so much of this course, as I said, is a survey, and is focuses on getting our hands wet on different approaches to these parts of the machine learning lifecycle, except for choosing the model, except for probably like focusing on training and feature engineering and all that. Okay, we are not going to focus on that. Okay. So here's a tentative list of topics. First, we'll deploy web servers. Sorry, we'll deploy machine learning models on web servers. In particular, we'll use a very popular web framework in Python called Flask. But there are many others. Some of you may be aware of some other project names like Django or Fast API and things like that. But this is just a proof of concept to show how web servers can directly take in the model that you built, maybe scikit-learn model, as I said, or a PyTorch model, and use it behind a web server. Okay. Second thing we will look at, this is not in order, it's just another thing that we'll look at is the Docker ecosystem. So many of you might have heard of Docker. If not, it's a very interesting piece of technology that has come up in the past few years, which lets you isolate what's needed for your model, for your machine learning solution from the actual system where it's running. Okay, so if you want to run, let's say, your machine learning model on a Mac, on a PC, or a Linux, or on the server, this technology allows you to do that in a very seamless way without worrying about all sorts of installation issues, system support issues, and all that. Okay, and Kubernetes is I guess this gets into more software engineering side. It's a way to orchestrate a lot of containers. A Docker is what is called a container. So we'll look into that. Okay, when in a few lectures. A third example technology that we'll explore is that of model tracking and model, I guess, scheduling. in particular, we're going to look at Apache Airflow as a way to schedule the machine learning pipeline. So in the machine learning pipeline, you would have um, a training phase, and the model, a data processing phase. For example, you need to fetch data from, let's say, a database, and then you would need to maybe select columns, maybe transform the columns, and so on. For example, that could be one unit of work. And once you get the transform data frame, you may call a training, a model, you may call a training step, okay, a training subroutine. And then you may also have a third phase, which is, once you have trained a model, then you want to use that model on a bunch of test users. You may have test user information over which you're making predictions and dump those predictions somewhere. Okay, for example, these 3 steps would be an example of a machine learning pipeline. And techniques like Airflow let you schedule this 3 sequence of steps. Okay, for example, step 1 should run at every day. Step 2, which is like model train, may only run every week, for example. And then right after that, maybe step 3, the model's prediction should be published. Okay, that can be achieved using some of these model management tools. Okay. Another thing that we'll look at as an example, as a name thrown here, is called Apache Kafka. It's a different way of thinking about data and predictions. Instead of thinking of data lying on a storage, like a file system, like on our computers, we'll think of data directly being accessible in some sort of a streaming system where data is never at rest. It's being passed on, bounced around between different components of the system, and we'll look into that. Okay. And we'll also look at, as I was saying, we'll also look at Spark. And so Databricks is a vendor which lets us work on Spark and try our hands on Spark and get exposed to it. Okay. And finally, as I said, we'll look at A/B testing. So there seems to be a lot of technologies. What we'll do is rely on a rough skeleton of how we're going to navigate through this, getting exposed to various parts of this ML lifecycle management. One good reference is this book called Data Science in Production. It was released last year. It's a $5 ebook which you can refer to. It's not necessary because most of the lectures will have all the code and notes available. Yeah. So any questions at this part about what is the scope of this course? I know some of you might have signed up without knowing much about what's going to happen in this course. So, okay, so I have a quick question to the audience, which is, how many of you are super new to Python? Maybe you can write on chat if you want, if you have never written anything in Python. Okay, so George is new. So is everybody else has, okay. Chaitanya is new. Okay. So everybody else has a little bit of exposure to Python. Okay, that's good. I'm sure, I mean, there could be some of you who are actually experts in Python. I see some names in the audience here, which is good. For those who are super new to Python, your approach should be like building Lego blocks. Okay, it's going to be, so you may not know the full details of the underlying, let's say, package, for example, but mostly you'll be focusing on getting a minimum working example, running to demonstrate, let's say, model dip. There'll be some details that we'll have to skip over, but that's fine. The objective, as I said, of this course is to just get our hands wet. So depending on your prior experience, it could be, the learning levels can vary. Okay. But so the course is structured such that most activities are going to be only in Python, and a little bit, there's going to be some necessary components on the command line. which actually can also be done on Python, but just as a um, um, different touch point. So basically between Python and trying to use the command line, we'll pretty much be covering everything that's needed for this course. Okay, so next let me talk about the logistics. So it's on Friday evenings. It's only one meeting once a week. So that means that the feedback loop is delayed by 1 week. So I really suggest folks to use the office hours, which are going to be right after the class, as well as by appointment with me. Okay, so yeah. Um, so try to really use the office hours, and maybe today after the class, maybe some of you can hang around, and also introduce yourself so that maybe the other students can get to know you guys. Okay.
Professor,
Yeah.
this is Anupriya.
Yeah.
I
Hi.
have a quick question. Uh, so the project will be group based, or is it going to be an individual project?
Yeah. So that's a good question. I'm hoping that the project is individual.
Okay.
So by the way, this course was only offered once before, and last semester. Some of you may be aware of it. So in that version, we had groups, uh, but we want to try out the opposite extreme this time. So projects will be individual. But at the same time, the project complexity is going to be at the level of a lecture. So as long as you follow through a lecture, you will probably have a project in your hands. And so people who are worried about not knowing much Python, for example, you will be fine. Okay. And folks who know Python, you can certainly aim for a little bit higher. And by the way, you will be in constant discussion with me, so we'll figure out how to get the best out of this course in terms of hands-on experience. Okay, and that's the objective of the project. It's just to get your hands more, like really go through a whole, exploring a technology related to machine learning life cycle. Because we don't have assignments, and that's I guess coming back to the original point about assignments, project, and grading. There will be no assignments. But every lecture comes with a bunch of exercises. So in the sense, they are assignments, but we will not grade them because, as I said, the class is a bit, as we saw, the class is a little bit heterogeneous. Folks, I know some folks know Python here, and some folks are relatively new, and maybe even looking at it for the first time. But you may have seen R, or you may have seen, like even if you know Excel decently well, you will be able to pick up Python, at least the basics of Python through this course. Okay. But since that's not the focus of this course, there's a separate course on Python, Introduction to Python. I would encourage you to take that if possible. But this course, whatever be your level of programming experience, you will get something out of it, as long as you want to know these parts of ML lifecycle. Okay, and these are actually becoming more and more important. I think 5-10 years ago, ML was not that prevalent, except for in some industries, some very data-heavy industries. But now that machine learning is now becoming increasingly important, it's good if business analysts, BI folks, data engineers, or even data scientists know the different parts of a ML lifecycle, and we'll see some snippets through this course. Okay. So coming back to assignments, as I said, no assignments. Project, there will be basically the objective is to demonstrate a deployment. If you want to do a deployment of a machine learning model, this is a good thing to try. Basically, the project's deliverable is a documentation of your process of going through this deployment process. It'll typically involve, when I say script, I'm talking about a Python script, so it'll have a bunch of commands to execute, right? If you've trained a model before, let's say in R, training a model in Python is similar, and actually model training and model details are not relevant to this course. So you can pick any model that you've already trained before, or maybe try to redo some model training that you've done from before in Python. For example, I know that in 572, there's all these simple data sets in R, right? Like housing data set, Boston housing data set, or the auto data set. Even those simpler data sets are fine, because we are not really interested in prediction accuracy, model diagnostics, and so on. We are just interested in hey, we already have a model. How do we set it up for the rest of the ecosystem? Okay. So I'm going to talk about projects in a little bit more, spend a couple of minutes on that. There's a link on, as I said, on the Blackboard side for project information as well as project upload. Grades, as you can see, will mostly be dependent on project, but since the class size is small, as long as you do interact with me, even if you don't execute like really well on the project, it's totally fine. It's again, the class is heterogeneous, so everybody will have their own benchmarks. There's no comparison between folks. Try to participate actively in the class. Talk to your other students as well as the teaching staff. I forgot to add. Um, there's a TA for this course. So you can reach out to me or her. Okay. And we'll be pretty active. We'll be monitoring our emails to schedule meetings online and get you through if there's anything as needed. Okay. So any questions about this part? Maybe I'll talk about the project first and then talk about the lecture schedule. And this, yeah, let me talk about the project. And if you have questions about the project, you can ask me now. So by the way, these links are available on here. Right. So the project has. Oops, it's not working. Oh yeah. Okay. Project links. Project instruction. It's here. It's basically goes to the Google Doc. Lectures link goes somewhere else. We're going to talk about that in a minute. And a syllabus link also goes to Google Doc. Okay, I may change the link back to keep all the links uniform and put everything on GitHub. But for now, these are just the links. Okay. Okay, so now let's come back to project. It's basically a exploration. You can think of this as an assignment, really, rather than a project. It's for you to simulate the real world experience, the real world process of deploying a machine learning model. Okay, and so you can explore any piece of technology that we're gonna look at in this course. Most folks tend to pick technologies or techniques which are in the first few lectures, but I certainly encourage you to try out things which come later as well. If certainly we will not have covered that by the time you are midway through your project, but there's always that issue. Yeah, so that's the objective, to really experience working with a technology that's introduced in the class, or you can also pick a technology which is outside the class, but mostly related to ML, machine learning lifecycle. Okay, so for example, here are things that folks did last time. So they picked a couple of technologies from one or two of the lectures, and they tried out the full process of deploying a pre-existing machine learning model, and they also did some analysis of, should I pick a certain solution 1 or a certain solution 2 for this model deployment. For example, these names may not mean much to you guys right now, but these are just choices that you can make when deploying machine learning models, and we're going to talk about these in appropriate lectures. Okay. Oh, here I do mention group sizes too. Oh wow. Okay. So let me go back there. Yeah, I think there are about 11 participants in this course. So a group size 2 is actually pretty good. Okay, so yeah, so I guess I take back my words earlier. I think it was Anupriya who asked me this question.
Yeah,
Okay, yeah. Okay, so actually the group size is 2. And so roughly it'll come out to about 5 projects, 5 teams or 6 teams. So yeah, so there is a group. Yeah. So, and the outcomes are basically, I am hoping, so last time there was no presentation in class, everybody did a video recording, and it turned out to be very professional quality because they had the time to do it, offline. But this time it's going to be a little bit online. So in terms of submission, you'll submit a report and potentially code associated with it. But in terms of video recording and stuff, there's no video recording. You just have to make a short presentation in the class. Okay, and we'll reserve the last lecture for this and try to see if we can fold in the content for the last lecture to a class before or something. Okay. Um, yeah, so there are some deadlines. Basically, March 5th is the last lecture date, and so the submission is due the night before. Okay. Generally, this project document also covers how to approach to how to communicate what you've done, what you've tried out in your project. So if you want a scaffolding, a reference of what to state in your report, then you can look at the report components. Grading rubric here, since this is a major part of the whole course grade, I'll spend a minute here. Grading rubric is mostly based on your presentation. Informally and more formally, it's based on your report. So the documentation is important. So and you'll see that in professional lives, the documentation is more important than the code artifacts that you compute or that you create. Um, so the grading for the report is mostly based on 4 aspects: correctness, content, creativity, and clarity. So creativity is hard to, it's a little bit subjective, but correctness is clearly it's objective. You should be very clear on what you've done, and there's no incorrectness unless there's some commands or some steps that you've taken. Content just is just based on what are you capturing. Are you doing things in detail enough, with sufficient detail, for example, and so on. Okay. And so these are self-evident. Now, finally, a point about, because this course will involve some technologies and that requires signing up with a couple of external, I guess, infrastructure providers. So you do want to keep track of infrastructure costs, especially if you're trying to do something which may cost. As you'll see in most of the lectures, it'll be it'll probably be zero cost. But this is something that you want to take into account, especially when you're doing a project. And also, I would suggest not to train expensive, complicated models, because that's not the objective of this course. If you already have trained something, something pre-trained from another course or something that you can use here, that's great. But we're not concerned about model accuracy. Okay. So that's about the project. Any questions before I talk about the lay of the land? So this will actually tell you what we'll learn over the next 8 weeks, and maybe give you a better sense of like things to come. Okay, so I think there was a question about, can you still do it in group? Yes, you can do it in group, Shivani. That group size was 2.
Oh, hi, Professor. This is Chaitanya. I have a quick question. So, for
Yeah.
the projects, is it like all the teams have same project and use different ML deployment techniques, or is it like everyone can pick their different?
Yeah, you can pick anything you want.
Okay.
So that's a pro and a con. It seems quite unstructured, but from what we've seen from the previous iteration of this course, folks, giving that flexibility to folks based on their domain expertise or based on their previous model build, so that they don't have to worry about the model itself. They can just worry about trying out the technologies, the things related to what we'll see in this course. Okay, and so that flexibility necessitates that folks have that freedom. Okay. So there is no specific, so not everybody will be doing the same thing. Maybe folks will do something similar just by coincidence. Yeah.
So you mean like in our previous courses, like 572 or 575, if we
Yeah.
already have a project with all the models, we
Yeah.
can use that built one to
Yeah.
do the ML deployment techniques.
Yes.
Okay.
Great. Yeah, that's exactly true. So if you already have something from 572, and I'm sure you have with all the assignments, and even if it had a project component, then this course is basically complementary to that. Okay, so you may have a well-trained model, but how do you actually expose it to the real world? Okay, in the sense that expose it to other folks in your company or to the real world if you actually are serving machine learning models predictions, for example, right? So that part is probably not covered in those courses, and that's why you're fine to take models from other courses. Yeah.
Yeah, thank you.
Professor,
Yeah.
Zanupriya again.
Yeah.
I have two questions. First, is the book available in hardcover as well, or is it only available in PDF?
It's available in hardcover. I think this is hosted on LeanPub. I believe. Let's actually open it. I do think I am not sure actually. Let's see.
Okay, it's fine. I thought if you knew, it would be easy for me. I'll just go and then buy it. Uh, Anyways, I'll search.
Yeah, I mean I only bought the PDF copy,
Yeah.
so yeah, I didn't check that it was actually had a hardcover or not. Sorry.
Okay.
Yeah.
And then second question is,
You don't need the book though. I mean, so by the way, for everybody else, it's not really critical that you need this book. I mean, most of the content is overlaps with the lecture notes. So if you find some other reference, that's fine too. Yeah.
Okay. And the second question was about what if we had all, like in my case, I have done all the projects in 572 or
Yeah.
575
Yeah.
in R.
Yeah.
So if those were in R,
Yeah. So you just have to figure out how to serve our models, right? So the thing is, I guess there was a choice that we made in this course because most, and we'll talk about it in a few minutes in this first lecture. We can still serve R-based models. It's just, I think it's a little bit more, I guess it's less mature compared to doing, less mature than doing things in Python. And certainly Python is not the way to do it if you really care about a lot of performance things. But it turns out that a lot of tooling has been made available in Python a little bit more seamless way than in R. But R-based model deployments are also feasible. It's just that we will not cover them. If you want to try out R-based model deployments, that's totally fine. Okay. So as we go through the lectures, maybe at some point, maybe I can just point out that you can do the same thing in R, for example.
Okay, thank you.
Yeah, yeah.
Professor, this is George. How much introduction should we have about cloud? I think a lot of these tools and things like that do refer to cloud, right?
Yes. Yeah, good question, George. So that's exactly, so the objective of this course is to expose you, really force you to get an account on one of these, any of the cloud vendors and try things out. So you don't have to know anything a priori, for sure.
Okay, perfect.
So today we'll try out one, creating a virtual machine on one of the cloud vendors. But you don't really need to know pretty much anything. And the point of this course is, hey, let's get exposed to the services available on the cloud. So that, like you may be really good at building machine learning models, but you can leverage the services, these are called managed services on the cloud, or you can even rent a machine on the cloud and do everything yourself. But leverage these things so that you can, expose your model eventually to consumers who can use your model and therefore derive value, right? Yeah. So you don't have to know anything beforehand, but you'll probably have to create accounts in this course. Yeah.
Yeah, that's perfect. And if you happen to know any book or videos that gives us a decent introduction to some of these cloud tools, I understand that the data science in production is the purpose of this course. I fully understand that and I appreciate that. But if you happen to know another book or another video that gives us an introduction to cloud, I would really appreciate that as well.
Yeah. Okay, I have noted it down. I'll try to find the right references because there are too many references, too much noise. I think if you go search for yourself, so I'll try to find something which is compatible with the level and is complementary to what we're doing.
It's most appreciated. Thank you so much.
Yeah. Okay. Any other questions? Okay. So I think what I'll do, I think in the next few minutes, I would say next 5 to 10 minutes, is actually talk about each lecture, and that's I think is a good use of time because I think some of you folks may still be wondering like what is going on in this course, as in like what will you learn, right? So And because ML lifecycle is a somewhat of a, I would say, informal term, it's unclear what are all the different components in a machine learning lifecycle. Um, uh, it's better to ground what the expectation is with each lecture. Okay, what are we learning? Okay, so we'll start with we'll cover much of lecture 1 today, but just to give you a sense of what we, so by the way, these references here that you see on my shared screen are the references to that book, but you don't really need the book, as I said. So let's talk about lecture 1. Lecture 1 is about, you have a machine learning model. Let's say it's a linear model, or let's say it's a SVM model, or I don't know if some of you have used XGBoost or even light GPM packages, or let's say you have a model built in PyTorch, okay, or TensorFlow, doesn't matter. So you have a model. The final objective of this first lecture is just to say, hey, I can rent a machine on the cloud, and it looks exactly the same as my local machine. And so let me spin up a web server and serve the model. Okay, and that, the web server. So there are three pieces. There's a model. There's a web server that uses the model, and all you need to do is expose the right IP address, or expose the right port, and you can actually access the model from anywhere on the earth, right? So you can just publicly access it. Okay, and that's what we're going to get to. Before doing that, we'll, especially for folks who haven't gotten started with Python, we'll see how to set up a Python environment, how to set up a Jupyter server, okay, and the notebook-based development process for tinkering with models. Even if you have a model, you want to tinker with a few other things to get the model set up so that you can actually serve it. And we'll see how to rent a machine on the internet. In particular, you can rent a machine, by the way. It's just going to look like exactly your desktop or a laptop. Maybe not have a GUI, or may not have a screen in the front. So we'll see how to rent one and log into it, basically. And finally, as I said, you will use basically a web framework called Flask, but it's a very simple. It's going to be a couple of functions in a Python file, which will let you serve the machine learning model, and we'll see that. Okay, so first lecture is just about, hey, if I have a model, I can easily rent a machine which is publicly accessible. So your local machine may not be publicly accessible because it may not have a public IP. Okay, even if it has a public IP, you may be behind a router or a NAT or something. So like I can't access your machine learning model directly. Okay, so it's good to rent a machine. One of the ways to do it is rent a machine on the cloud, basically. A machine which will have a public IP address, and then if you can put your model in that machine, then it's an easy way for anybody to access it. Surely there is concerns about, hey, if everybody can access it, then I'm going to run a lot of expenses serving that, trying to make predictions every time and so on. There are those things. But the objective of lecture 1 is just to put your model in a publicly accessible place where you can send a query like, hey, tell me the prediction for the weather. So if there's a model which predicts weather, you send an information like location, hey, what's the weather in Boston, and you'll get back information about, hey, the weather in Boston. If there's a prediction model behind it, we'll say what the weather is. Okay. So anyway, that's the objective of lecture 1. In the second lecture, we will now try to use some of these cloud features. Okay, one of the benefits of going to the cloud is that these cloud service providers, or these infrastructure providers like Amazon Web Services or Google Cloud or Azure, they will try to create what are called managed services, which try to make your life easy. They'll say, hey, you don't worry about the machine turning off, that machine will not turn off, okay, and we'll restart it if needed, for example, right? You don't have to worry about security, we'll take care of that the machine is secure, for example, and things like that. Okay, so one of the we'll look at one one piece of technology that the cloud providers provide. It's called the serverless technology. it's really an oxymoron in the name. It's not really, I mean, there is going to be some server on the cloud which is going to serve your machine learning model, but it's just that it's completely agnostic to you. So you don't have to worry about anything. You just focus on your model, somehow push the model onto their solution, which is a serverless technology, and it'll take care of everything else, okay, which is the web server part and IP address part and all that stuff, okay. So in that lecture, we're going to talk about what's the difference between hosted solutions and managed services. As I said, managed services are the things that cloud vendors provide so as to make our lives easy, okay. And in particular, we'll try to use two different. So for the same technology, just as a way to see that multiple cloud vendors provide the same type of solution, we'll do that. We'll deploy the same ML model. Okay. And by the way, throughout this course, we're going to use recommendation systems as an example. So we'll deploy a recommendation model. We'll deploy the same model in a serverless technology by Google. It's called Google Cloud Functions, and serverless technology by AWS. It's called AWS Lambda Functions. Okay, and as I said, we'll not go through the depth of any of these technologies. We'll just do the minimum to get a feel for, hey, this is how a serverless technology deployment would look like. Okay. Next, we'll move on to the use of containers or Dockers. So we'll try to understand what's the advantages and disadvantages of container technologies. As the name says, it's like a container. It's like a box, okay? And the box will have our machine learning model inside, and the box can be placed anywhere, whether it's on a Mac or a PC, inside a Mac, inside a PC, or inside a Linux machine. It somehow isolates things running inside the box, like our machine learning model, which needs to make predictions, and things outside the box. So in that sense, it's somewhat, it creates a lot of advantages like portability. You can move the box from, you can develop the box on your local machine, and if you send it to the server, even if the server's machine is different, maybe it has more RAM, or it's running a different operating system, your box will still run and still be able to make, will still be able to make predictions. Okay. And so this box analogy, we're gonna look at a popular vendor or popular technology that realizes this concept. It's called Docker, and so we'll see how to use Docker to be able to do this, to be able to serve a machine learning model. Okay. And there are some minor details about how to do it, and so we'll just get exposed to how to do it for our recommendation system. Okay, example. In the next lecture, we'll go one step further and talk about a technology which I think it goes a little bit closer to folks in the software engineering side, or I would say software engineers. It's called Kubernetes. It's just a system to manage these boxes. So, for example, you may have a machine learning prediction model in a box. Somebody else may have a data cleaning, code in a box. Somebody else may have a, the website for the business, like the client in a box. So all the boxes can be on the same infrastructure, and there's a management a piece of software like Kubernetes can manage all these boxes so that all the boxes stay alive, in the sense that, for example, they don't crash. Even if they crash, they can get recreated and things like that. Okay, so that's called orchestrating ML deployments, and we'll look at one technology to do so. Okay, and again, all this has a lot of depth, but we'll try the minimum viable examples. Yeah. Yeah, and we'll do that on our own local machine. There's a way to do it, way to get experience on how to orchestrate, how to deal with these containers, as well as on the cloud. Okay, and on the cloud we'll use, for example, Google Kubernetes engine. Okay? And these are all, by the way, you don't need any programming background. For us, these are black boxes. We just need to know what roles they play and how to start them. And most of the times, for example, in Google Kubernetes engine, it's going to be clicking through a few user buttons to set up something. You need to control your model. The cloud will help you deploy it in a scalable way, in a really nice fashion. Okay? And we just need to know what help is available. Next step is about ML model pipelines. And this is where I think at the beginning of the class, I mentioned that you could have a data cleaning step where you get the data from maybe you write a SQL query, which queries data from a data warehouse or some other location. That could be step one. That's one job. And the second job is maybe use the data, process data to train your model. And that's second job. Maybe there's one more job or a unit of work, which is like, hey, you now we have a model. Let's make predictions on a bunch of test data and put those predictions on in another database, let's say. So there are three steps. They need to be executed sequentially. There are tools to make us, to let teams, especially businesses, automate this away. Like, hey, if step one finishes, let's do step two. If step two finishes, let's do step three. Instead of manually, like running the scripts yourself on a server machine, for example. Okay. There's also running of jobs at regular intervals of time. For example, every night you may want to update your prediction models for, let's say, you're forecasting weather. You want to update your prediction model every night, let's say, to get updated predictions for all locations, all cities in the US for the next day, okay, in terms of weather. So that means that you need to retrain your model potentially every night, or maybe regenerate your predictions every night, if not retrain. And so you can do that by scheduling scheduling this retraining process and so on, okay? And there are different, a couple of different tools to do that, and we'll get exposed to them, okay? Finally, this is the intersection with IDS 561 for folks who have done 561 big data. So here we'll look at Spark as a way to deal with really large data. So think of data. So think of your laptop, right? So you have, let's say, maybe 1 terabyte of disk space, or maybe 500 gigabytes of disk space. Now think of a data set which is 2 terabytes. Okay, that certainly will not fit in a laptop. How do we deal with data when each individual, like any single machine, may not be able to even load the whole data set? Okay, maybe even not even store the whole data set. And that, exactly is the problem solved by Spark, or a Spark ecosystem, where there's this notion of a cluster. Data is split between several machines in a cluster. A cluster is just a collection of computers, and you will be able to run, let's say, like you can just work with a data frame. Okay, so in our data frame, folks who have done R, they know there's this notion of a data frame. Same thing in Python using the pandas package. So similarly in Spark or PySpark, there is the notion of a data frame as well, and it makes it agnostic to us that there is actually underneath the data frame is actually multiple computers holding parts of the data. But with just a data frame, which is viewable by us, we'll be able to do many of the operations that we are familiar with, like dropping columns, indexing columns, conditional indexing on columns, and doing various other things that you do in a typical data science workflow. Okay, and so we'll look at PySpark. As I said, most of this lectures are in Python. Pretty much as much of it can be in Python is in Python. So we'll look at PySpark, and in particular, we'll use a tool called Databricks. A vendor called Databricks to explore PySpark. Okay. And how does Databricks look like? It just looks like this. This is the interface for Databricks, and you can get an account for free. And so we'll do that. Okay. When we get to that point. So that was just a quick teaser to show what Databricks looks like. But let's come back to the last couple of lectures. Okay, once we have at this point we have seen deployment directly on a web server, using serverless, using containers, 3 different ways, and also orchestrating it using a Kubernetes technology, especially if it's a it's not just a model to be to run predictions on, but also extra things, which means there are more boxes. And then also how to schedule your deployment. For example, you need to retrain your model. Can we retrain every night? Can we retrain every couple of weeks? That is captured by lecture 5. Lecture 6 is about, what if your model needs a large amount of data, to train? Then how do you deal with large amount of data? That's where Spark ecosystem comes in. Okay, and lecture 7 is about hey, what if data is not available as a batch? It's not like you can run a query on a database or from the data warehouse that you collect, let's say, this 1 or 2 terabytes of data. Okay, it's not at rest anywhere, in the sense that so the data is coming maybe from your clients. Maybe you are in a business which involves it's consumer facing business, and it's an app. Then data is coming directly from phones of your customers directly to some location. Okay, so these are called streaming situations. Okay, and so the appropriate blocks of making predictions when data is coming sequentially in some sort of like a it's not, you're not explicitly reading it from disk anywhere. So that different mode requires a little bit of change in how models are deployed, and that we'll look at. Okay, and that's actually something that's also supported by Spark, so it's not going to be a big delta here. And we'll also look at a piece of technology that I was mentioning earlier, which is called Apache Kafka. Okay, and all this we'll also do in Python. And finally, as I said, there's going to be A/B testing. A/B testing is very fundamental, especially these days when people want to make decisions. They want to make decisions using data, and so and one way to do those decisions is to run A/B tests. Okay, and folks who are in, let's say, healthcare area, you would know these are better called as randomized controlled trials. So it's just blindfolded trials where, hey, I have to, let's say, product A, product B. Let's randomly show the product A to some bunch of people, and another product B to a random set of people, and see what their let's say preferences, and maybe product A wins or product B wins. Okay, that's what all A/B testing is about, and we'll see how to do it again in Python as a minimum working example. So that's the 8 different subtopics we'll touch in this course. There was a question which I'm just reading now. It's about boxes as in Docker. Yeah, Docker is a implementation of the idea of the container idea. When I say boxes, it's just think of boxes themselves as containers, and Docker is a way to implement them. Okay, and there are actually competing technologies which do the same thing, which also build boxes, if you want, if you will. Yeah. So any questions about this?
Hi, Professor. This is Laura.
Yeah.
I just want to go back to the concept of boxes. So the boxes contain a machine learning like deployment or something like that. Is that what you mean?
Yeah. So think of, so are you familiar with Python, or are you more familiar with R?
I'm familiar with both.
Okay, so just think of a box as it's basically like it's like a virtual machine, but really lightweight. Okay, so what it will contain is just your Python script and maybe a model like pickle file or whatever file it is. Okay, let's say so typically when you train a model, after you train the model, you have to save it somewhere. Generally, you will save it as what is called a pickle file, or even if it's a linear model, you can just save the coefficients as a CSV file or something, right? So something like that. So what I'm saying is a box is nothing but a really lightweight virtual machine, which inside the virtual machine is just going to be your Python script to be able to serve your model, okay, to be able to make predictions.
Okay.
Yeah.
Thank you.
Yeah.
I had another question about the A/B testing models.
Yeah.
Would that mean that there's like random models that are deployed and then you see which one is like working best and then you choose that one?
Yes. Not random models. So offline, you can have some confidence that which model is good or not. Okay. So for example, you collected data, and your manager gave this data to you, and you build some recommendation system. Okay. And folks who are familiar with recommendation systems, there is some metrics like they're called hit metrics, like precision and recall. I think some of you who have done, who have looked at precision recall may know it, but just think of this as metrics like AUC or MSC and so on. Okay, mean square error and so on. Okay, so offline you can compute these numbers, right? You can hold out some test data or validation data, and on that data you can compute mean square error or precision or recall or whatever it is. Okay, but that doesn't mean that that what you built, the recommendation model that you built will actually do well in reality. Okay, so what companies will do is there's already an existing recommendation engine or recommendation model already making product recommendation, let's say on an e-commerce site or on Netflix. They'll say, hey, let's look at let's randomly expose a small population of our users, let's say 5%, to this new model. Okay, so the new model that let's say the team has developed. So we'll just get a sense of how good this model is on this small percentage of users and see how it compares to the existing model. So the existing model is already serving 100% of the users. Let's take a small chunk of it, a chunk of them, okay, let's say 5%, and expose those 5% of your users to the second new model, and you'll get a quantitative value of, hey, is it actually working in reality? Okay? Because it's working in reality. Some evidence of it working in reality is better than these offline numbers that you compute using, let's say, validation data set.
Okay. Okay. Thank you. Thank you for the explanation. Appreciate it.
Okay. So with that, let me go. So we're going to start lecture 1 at this point. Okay, so what I will do is actually show you a tool, and I'll also show you how to get started with this. So let's, so everybody can see my screen, right? So this is a different tool. This is not the browser. This is it's VS Code. Okay, it's an editor, but we'll get to how to get it set up pretty soon. Okay, so you can see the left-hand side, which has a bunch of, I guess, uh, files, right, at the top. Lecture 1A, basics, SSH and Firewall, Python, and so on. On the right, you see some text, and that's what I'm going to go through in the next few, next remaining part of the lecture. Okay, so let's start with. Okay, let's actually close this. Yeah, let's. So I'll show you how to get to this point. If you want to use VS Codium, you can also use VS Code. If you also want to use something else, we'll get there. Okay, but for now, I just want to get started with some discussion about web servers and choice of technologies and so on. Okay, now before I really get into that detail, let me actually come back to this browser. And when you go to the content page and click on lectures, as I said, there's a link to lectures. If you click on that, you should be able to get to this GitHub link. Okay. So let's click on it. Okay. So you'll see some bunch. You'll see a bunch of files here. Now, how many of you are not familiar with GitHub at all? Okay, can folks write it on the chat that you are not familiar with GitHub, like no or something? Yeah. Okay, so GitHub is just a it's a free service being provided by I guess Microsoft. You don't have to use GitHub. Git is a technology which allows people to collaborate on code, just like Google Docs allows folks to collaborate on document writing, or Notion, if folks have used Notion.io, things like that. So it's a collaboration tool, in particular for coding. Okay, so you can create an account. It's free. And most of the lectures, I'll try to put it on GitHub. And one of the reasons, actually, not the main reason though, one of the reasons is that you will want to get familiar with Git as well. Okay, Git is a very nice tool to know, and I think it's good to know in this course, if you have not been exposed to it elsewhere. Okay, so if you can access this link on the UIC, from the Blackboard page, you can actually click on any one of these files. Okay, in fact, let's say lecture 1A, it'll actually show the same text as I was showing a couple of minutes ago. We can actually go through stuff from here. Yeah, so let me actually go from here instead of showing the. Actually, maybe I should use the VS Code just so that it's a little bit different. Do I have it as an open link? Yeah, actually, can let me copy this. Yeah, there's no sign up required. Yeah, definitely not sign up required. If you want to create an account, you can. If you want to host similar things, okay. And we can talk about what is hosting. What exactly is this website doing? We can talk about during the course. Okay. So, but for now, if you just want to use the, if you want to see the lectures, these lectures are basically text files. Okay. And this extension IPYNB just means it's an IPython notebook. Okay, and it's about Python. So actually, these are code blocks. These are supposed to be code blocks, but right now it's just a text block. So code can be mixed through into this, and it's related to Python. So we're going to talk about it, how to get Jupyter running and how to get an IPython notebook experience pretty soon. Okay, some folks have experience, in fact, extensive experience with GitHub. So do correct me if I say something a little bit. I'm trying to be informal here. If I say something wrong, just do let us know. Okay, Srivani. So, okay, so we'll start with the first lecture. As I said, the scope for today, and we don't have to really be fast and cover everything. Okay, so folks who are really who know a lot of these things beforehand, you can certainly leaf through things that we may not cover during the session. Okay, so I would like to go a little bit slow, especially for folks who are a little bit new. But do let me know if I'm too slow. Okay, so that I can speed up in some parts. So as I said, the objective for today is to get machine learning models onto web servers. Okay, and actually what you'll see is the challenge is not so much about running a model on a running a model because running a model, like if you open R, RStudio, or if folks who work in Python, you can just call Python file name.py and actually run your let's say training notebook or training file or something. Okay, the challenge is to really get familiar with web servers. So these are the topics we'll cover. First is some things about about web servers, including what is called SSH as a technology to log into the web server, and the notion of firewalls. Firewalls, I think everybody knows. It's just for security. Next, a couple of topics are about just getting started with Python. Okay, so Conda is a very nice way to get ease into Python. Okay, it does a lot of things behind the scenes so that your Python experience on your own machine, whether it's Windows or Mac or whatever Linux, is smooth. But for advanced users, you can certainly don't have to use Conda. By the way. The third thing related to Python is this notion of a Jupyter notebook. This screen or this page, as I said, it says lecture basics.ipynb is actually actually a Jupyter notebook, and we'll actually get to creating a Jupyter notebook in somewhere towards the end of this lecture. Yes, the question was, is Conda the same as Anaconda? Anaconda is the name of the Anaconda is the name of the I guess Python distribution software by a company called Continuum, and Conda is the name of the command. It is the same in short. So and then we'll look at how to make requests and process responses. What does make requests and process response mean? So whenever you have a web server, okay, it'll have an IP address, and just like a website, right? So if you go to let's say my website, we are making a request. Hey, show me your homepage, and the server on the other side is saying, hey, there was a request for showing a homepage. Let me send the homepage information to this client. Okay. Generally, the request is made by a browser. We'll see how to make a request on the Jupyter notebook so that we can ideally want to make a request to a machine learning model, okay, which is on the server. So that's the motivation for this step. And finally, before we can making requests, we ideally want to make a request to our model being served on the web server, and that model will serve using Flask as a thin wrapper around the model, so that it is able to respond to a request and say, hey, can you make a prediction for some test input? Here's the prediction. Okay, so Flask is going to intermediate that getting the request and asking the model to spit out a prediction and sending that prediction back to whoever made the request. Okay, and if it's a browser or if it's someone outside, and there's some minor points. I think let's not discuss it at the moment. And we can also use different techniques to work with Jupyter notebooks, not just directly. So yeah, I'll talk about VS Code a little bit later as a way to work with Jupyter notebooks as well. Okay. So anyway, let's come back to the origin, right? So Python. I think at the beginning I asked everyone if you know Python. It's totally fine if you don't know much or anything about Python. It's basically very similar to R in terms of its ergonomics. Actually, if you really want to get started with Python, like one great way to do that, without doing anything on your own machine, is to go to Databricks community. Community.cloud.databricks.com here, and create a account. Or if you already have a Google account, like let me go to let me go to Drive. Actually, Drive is not necessary. Let me go to research. Okay, actually, I think it's called collab.research.google.com. Okay, so let me see. Yeah, so you can open these two. So you can open the latter one. Actually, it's much easier. And in fact, if you want to open the current notebook, I told. Okay, it's saying it's just. So if you want to just open the lecture notes, I think I showed you. You can just click on the Blackboard link. You'll get to this page. You can click on basics, and you'll basically see the lecture notes here. If you want to see the same thing in, let's say, on Colab, you can also do that. You can just write http/ and you'll be able to get to the same notebook, and you'll see any of the lectures here. Okay, so as I said, these are text files, but a little bit special for Python because you can run code within them. Okay, so let me actually open that, and let me add a code block. Okay, so let me add a code block. So so this is Python. So if you don't want to, you want to get started with Python in a little bit easier way, then using this link collab.research.google.com, and trying out Python like commands and so on, you can do it here. Okay, will we have access to the lectures post course? Yeah, so this whole lecture stuff is if you want to just get this material, it's a public repository. Okay, it's just to make everything access easier. And the reason why I wanted to do it like this way is so that you can really play around. Even when you're looking at a lecture, you can literally open it in, let's say, Colab, and start writing Python code. And you'll see that it's very similar to R for the folks who have looked at R before in 572. So you'll have access to all this all the time. Okay, so even post course. Yeah. So anyway, so I think I digress there. But so if you want to get started with Python, so Python is a ecosystem which has a huge advantage in especially data science. In particular, a big advantage is that it's a general purpose programming language, which is quite beginner friendly. So what you typically develop in your local system, like Python scripts, which are very similar to R scripts, you can easily move them to the cloud. Okay, and we were talking about different ways to do that. We can use our own web server, we can use the serverless technology in next lecture, or using these containers of the notion of Docker in a couple of lectures later. You can do all that by just writing one script. And can we download the IPython notebooks from GitHub? Yes, exactly. So you can actually do that. So let me show you how to do that in real time, because there's a question here. So yeah, so we are jumping a little bit ahead. So where did I get this? Don't worry about it. So you can get the documents from GitHub either using a terminal or just using Sorry, what happened? This is either using a terminal. So you will see something like this in Mac, for example. There's a terminal app, or in Windows you can get the PowerShell or the command CMD thing. You can actually download it using it. I mean, it'll actually show you the command to download it. So let me actually go back here. So by the way, this page, if you have not yet accessed, let me paste it here for those folks who are trying to find the link. So you can just see download code. So you can actually download the zip file directly. So if you click download zip, it'll just let you download it. Otherwise, you can use this link here. So it says https GitHub and all that. So let's copy it, and we can just do git clone or something like that. So if I do, so let me not clone it into the notebooks directory. So if I type git clone and that URL that I got, I'll get a folder. Sorry, I'll get a folder called that folder name. If I cd into that folder, then I'll be able to see all the notebooks. Okay, so this is a notebook, and if I want to access that notebook, I can just run a Jupyter server, and I want to show that Jupyter server in a few minutes. So let's wait for that. If you don't want to wait for it, the teaser is that temp folder I just created has that, that bunch of files that we downloaded. You can click any one of them locally and you can open them as well, instead of using the Jupyter notebook. Instead of using the collab stuff that I was showing. Okay. I hope it didn't confuse everybody. Let me come back to lecture one here. Okay, we're still discussing about Python. Okay, but to the folks who are really eager to try on something, there are many ways to get to do the same objective. Okay, and that's what you'll see in much of this course, that there's 2 or 3 different ways of doing the same thing. But we are looking at the notebook from here. This is not interactive; it's just text file here. Okay, so I don't want to motivate too much about Python, except for saying that it's a really big player in the data science world. It has some really nice ways to access database, external things, and also do things which are not related to data science. Like basically serving machine learning models. Okay, using, for example, a web framework like Flask. So that's, these are the strengths of this language, and it turns out that a lot of data scientists, a lot of business analysts, a lot of folks, statisticians are also using Python. So it's really good for us to learn Python, at least through this course. Okay. Although in this course, as I said, the emphasis on trying out deployment with a lot of black boxes. So I think the amount of code you need to just try out black boxes is quite limited. Okay. And so you'll probably be able to pick up Python through this course. So as I said, our objective is to learn general patterns, not master the specific tools. And so it'll be a first exposure to operationalizing machine learning for many of you. And some of you, it may be, some of the tools are familiar, like GitHub, for example, for some of you. As I said, again, the expectation is that we only be scratching the surface. 8 lectures are not really enough to do justice to each one of the topics that we're picking up. So we are really focusing on minimum working examples. Okay, and this is what you will try to do. In every lecture, there's going to be a corresponding. For example, if you see lecture 1 has this file called exercises. If you click on exercises, it'll give you some directions of what you should try to do offline to get acquainted with more acquainted with the what we're talking about in the lecture. Okay. So let's come back to the world of web servers. Whenever we have let's say we have a machine learning model which is ready, there are many choices of where to host it, as in like where to put it so that it can be put to use, right? So we can put it on what are called on-prem or self-hosted machines. Okay, on-prem means on-premises. It's just a shorter version of that word. These are basically machines that it could be as simple as your own local machine, okay, your own laptop, for example, as long as online all the time, or you can rent machines from many different vendors, including here are some vendor names. Okay, most of it may be new to you guys, but these are all companies which will say, hey, here's a machine that we can rent to you for $5 a month or $10 a month. You can just rent a machine and put your model there, and that makes it one step closer to making the model available to the world for whatever $5 to $10 a month, and it's always online. Okay, so it'll always be on whether you turn your laptop off or not, right? Not just these, actually, companies like Azure or Microsoft or Google and Amazon, they also provide these types of machines, self-hosted machines. But their strength is not just to do that. Their strength is to provide many auxiliary services which enhance the use of using cloud while deploying machine learning models. Not just machine learning models, they're also useful for everything else in software, software world. But for machine learning models, in particular, they do a lot more than just letting you rent a computer where you can put your model, where you can put your model. So these are called managed, I guess these are called managed clouds. And so they manage just means they have a managed services. So nice browser, like nice URLs or nice pages where you can configure different things. Maybe your model has to be making predictions a million times a day. So which means that maybe you want multiple copies of your models running on multiple machines, and then it can all be unified. It can all be shown by a single IP address, for example. Okay, all that can be done in a very click and deploy type of a style on these managed cloud providers. Okay. The decision to deploy where can you deploy, whether it's on the cloud using managed services or on the cloud, but just rent a machine or two there, really depends on a lot of things, especially the skills of the team which needs to do that. For example, if it's a new team in an industry which is not very which doesn't have ML lifecycle best practices or software engineering best practices, then you should go for something pretty simple like what we'll see in today's lecture. Okay. Sometimes there's also some businesses need scale. Like if you are at the scale of let's say Instagram, then these images are like consume so much space. You need to do a lot of machine learning on them, for example, to filter out illegal content or copyrighted content or things like that. So there's different use cases, and that requires different levels of different choices of whether you'll do things on your own or whether you'll do managed cloud. Okay. Fortune 500s will have full-fledged teams, and so they will have what are called DevOps engineers. Their role is to ensure that machines run. So they don't care about what's running in there, but they care about, hey, the machines are not failing, the network is up and everything like that. So if there are teams like that, then maybe on-premise solutions are a great choice. Okay. Similarly, if you're working with healthcare data, maybe on-premise solutions are better because the data never leaves your company. Okay. And there are many other concerns like costs and so on. Okay. But on both directions, both whether it's on cloud or whether you're self-hosted machines, there's going to be a big challenge, which is that both are relatively hard. Okay, so local deployments are definitely hard because if, let's say, especially for a data scientist or a business analyst, we need to know, if we know, local deployment just means, using renting a machine either on the cloud or, something, a server on in the university or something like that. You as a data scientist, you certainly build models well, but then you'll have to also be concerned about, hey, is the server, secure enough and not, if let's say it's a healthcare based model, healthcare, in the healthcare space, then you definitely don't want, data leakage, for example. You need to also learn how to manage access. Do I physically go to the computer and do something over there to manage my models, like let's say change or update my model? How do we even change the model? Let's say you want the model to be always available. Okay, whenever your clients, your clients expect your model to be always running. Then let's say you came up with a new model. How do you hot swap, as in remove the previous model and put the new model? It's those things are hard to do, and you certainly need your own ideas for how to back up the whole system. Okay, maybe, and these are not trivial things to do. That's why you need these folks, DevOps folks, to do it. Okay. Cloud deployments are also not easy, especially if you log into AWS or and we'll log into a vendor today and AWS later on in the subsequent lectures. You'll see that there's so many options. Okay, and half the time we don't know what is that new option, what is the new service that these folks have rolled out. Right, they keep rolling out something every 2 months or every month. So that also is a challenge. And there's also this notion of vendor lock-in. Okay, so maybe if you really integrate your solution on AWS, you're kind of stuck with AWS, even if the cost for some other service which you really need happens to be super high. Okay, so you may be locked in and you can't really step out and use some other cloud easily. Okay, so now, so those are the concerns. Now, coming to software tools for us, as I said, we are mostly focusing on Python. We look at, Python development itself can happen anywhere. Okay, by which I mean, you can write your Python commands, in text file, just like R, right? R, you do not really need RStudio. Actually, you can write your R commands, in one below the other in a text file, and you can run that script on the command line, for example. Okay, or on the R's native, I guess, GUI. But you can certainly use text editors. You can use what I call integrated development environments, and VS Code is an example of that. It supports Python, it supports JavaScript, it supports C++, Java, any of the languages. Like Ruby and things like that. So you can use IDEs. For Python, we can also use Jupyter notebooks. And here, this was the example of a Jupyter notebook. So where was this? So this is the Jupyter interface where I can, let me go back to, let's say, temp. Like I can create a new notebook. Okay, and what does a notebook do? It just gives me a nice interface. It's very similar to RStudio's, right? RStudio's interface it's a little bit different, a little bit similar. So and let's say yeah, so this is what a Jupyter notebook is. Okay, and in fact, our notes here, this is also a Jupyter notebook. The difference is basically that what is this? The difference is that I can I can write, this is text. Okay, and I just need to change the type of the cell to what is called markdown, but it's just a text notebook, and insert it. Okay, so there's actually a cell here, but it's just text cell. Okay, and you'll see that most of code is text cell. Now let me come back to the question on the chat, by the way. So there's a question of why to use VS Code. So, okay, that's a great question, actually. Thanks, Shivani. So let's come back to our notes here. Yeah, so VS Code or PyCharm is another competitor. These are called integrated development environments. They actually they actually enhance developer productivity by providing a lot more than what a text editor can provide. In text editor, there is no support for like something trivial, like let's say you want to rename a variable, okay, and the variable happens to be at 10 different places in your long script, okay. With VS Code, and this is just one simple example, you can actually select the variable name at one location, right click and say, hey, find the symbol everywhere else and rename the symbol to a different name, for example. Okay, you can do code completion. You can do, it'll actually do a lot of, it'll flag a lot of potential errors. You can also do what I call breakpoints. I think. And many other features. Okay, so development environments let you do a lot more with the language than a text editor. Now, so can we use VS Code as a text editor? No, that's exactly, that's a great question. I'm not actually using VS Code as a text editor. Let me go back to my VS Code page. So you can see that it's actually not a text editor. It's you can see at the top, there's a Python Jupyter server running, and there's something called Python here. And the reason is that this is actually a Jupyter server. So this is actually the same as seeing what we were seeing in the web browser. So here I can, for example, I can run the same thing. So here it's a code environment. So print, you know, so I can run the same thing. Okay, so this is actually a code edit. It's actually very similar to Jupyter Notebook. Okay, as I was saying, you can actually also see variables. So for example, let's say a is equal to 2, 3, and 4. So let's see if it actually show variables. Okay, so yeah, you can actually do this variable exploration. You will not be able to do this on a regular text editor, right? So VS Code is not just working as a text editor for this notebook. It's actually a full-fledged Jupyter notebook environment, basically. Okay, so you can actually get the same thing even on Jupyter Hub, something called Jupyter Hub. Yeah, something called Jupyter Hub.
So, Professor, you're just trying
labs,
to
right?
get to the different environments. That's what you're showing us, right? Like how to access or write code in different ways. That's what you're trying
Yes.
to accomplish.
No, I was just trying to say, what is the need for VS Code? There was a question about what's the need for VS Code here.
Yeah, no, we use Visual Studio extensively, but I was trying. I'm very new to this VS Code, so that's why I was
VS
trying to
Code is different
understand
from Visual
how.
Studio itself. Okay, VS Code is more focused on JavaScript, and so Visual Studio itself is for Microsoft languages.
Right.
But this VS Code is just it's a more lightweight IDE. It's actually an IDE as well. Okay.
Okay, that's what when you said that I was thinking the same. Yeah, it's okay.
Yeah. Sorry, I mean, so by the way, me switching, so by the way, I was planning to not jump over too much on these things, but so let me close the variable thing. So I was at this point, right? I was saying tools. Okay, so this text that I'm seeing here is exactly the same as the text I was showing on GitHub, the text I was showing on, let's say, Jupyter server. Okay, it's all the same thing. It's the same text. And you can also download, as I think earlier I showed you, you can go to the GitHub link that I shared on the chat earlier. You can download the notebooks. It's just that if you open the notebooks directly on a text editor like Notepad or something like that, Sublime Text, then you'll see a lot of extra metadata. Okay, since these IPython notebooks, although they're text files, they have extra markup. Okay, and it's better to see them either directly on GitHub or on Google Colab or on VS Code or something like that. Okay.
Got it. Thank you so much.
But I don't want to confuse the beginners. For beginners, let's just stick to GitHub for now. Okay. Let me go back to GitHub. So yeah. So what we'll do, we have already 1.5 hours into this. So let's take a break for 10 minutes, and I'm going to discuss what we'll do today. And I'm going purposefully a little bit slow. It's not, as I said, it's not super important that we cover every aspect that are there in the notes. But at the same time, it's important to stall a little bit and actually discuss what we're doing at each step. So we'll do that. Okay. So let's take a break for 10 minutes. Resume at 7:41. Okay, so before the break, we were talking about software tooling associated, which can help us with getting started with Python. Yeah, so for the next, second half of the session, we're going to take it a little bit slow. So what we'll do is probably the first part, because I want to do it a little bit slower. What we'll do is we'll use one of the cloud vendors. I just picked DigitalOcean, but we can use AWS, especially I think for new users. AWS provides a free computer to rent, a free instance to rent for pretty much free. I mean, yeah, it's free for about a year. But I'll just use one just to show you the flow of how to get a sync set up. Okay, once you set up a machine, unless you like turn it off or basically delete it, you can actually keep logging into it and try different things, and so you're decoupled with all the installing software on your own machine and all that. Okay, so that's what we'll try to do. So we'll try to use a vendor. We'll try to use a way to access that machine, and then we'll set up. We'll try to make the machine a little bit secure, and then we'll install Anaconda. So Anaconda, as I was saying, is a way to get Python. You can certainly install Python directly, and so we'll talk about how to get it done. Okay, and then we'll start the Jupyter server. So the end result will look like this. Okay, the end result will look like this. Something which says, hey, instead of localhost, it will be the IP address of our machine. Okay, and I'll show you the public IP. And this is what I meant by, if you're on a web server, if you put your machine learning model there, you or whatever clients or customers can access that model for making predictions from anywhere. Okay, of course, there's this need for authentication and all that, but modulo that, instead of this local host just means it's running locally here. Instead of that, we'll try to get it on a web server. And finally, we'll be able to access this interface from our local machine. Okay, so basically on local machine, we'll type some IP address, like it's basically like a website name, and we'll get to our machine, which we rented on any of these cloud vendors, and be able to do anything related to Python. Okay, so any questions about that part? So before that, okay, so with what I'll do is, let's see. So since we need to set up, we'll need to use DigitalOcean. Is it open? Okay, this was a book. Okay, so let me close Databricks and all that. It's just, it can be used later. Okay, let's, yeah, so I was talking about Conda environment, right? So for that, we just need this website. We need to go to this website. I can paste the link. I think it's probably also there on the course page. Okay, so this is not the starting point, but this is where you would get a version of Python. Okay, a nicely, I guess, packaged version of Python. But before that, let's actually get a server for ourselves. So let's go to, I actually have it bookmarked here. So let's go to digitalocean.com. Okay, so this is one of the vendors. What it gives is a bunch of what they call droplets, but these are basically machines for us to rent. They also do a bunch of other things. That's why, this is one example of a cloud. These are, this is, they do, as it shows here, they can help with computation. They can help with, creating databases. They can help with, something related to networks, which, we may need. And they also help with storing, okay? So, but, let's start with signing in. I actually have an account already, so I'm going to use mine, but you can use any. You can create an account. Okay, let me actually put a disclaimer that you don't have to do this here, because I think this creating a machine here requires you to enter your credit card information. But it's not a bad idea to try it. I mean, it's not expensive. Okay, save it. Wow, some two-factor authentication. Yeah, you guys can see my screen, right? For this for the browser. Okay, let me see if somebody replies on. Oh, do you want to sign up with personal email? Oh, it actually doesn't matter. I would suggest personal email is fine. So you don't have to actually do DigitalOcean. This is just an example that I want to run through in the class. you can actually use AWS. If eventually we'll switch over to AWS. I just wanted a variety, that there are other things in addition to AWS and GCP, Google Cloud. You can use any email.
The only thing I'm asking is, like, I know you mentioned some pricing or something. So I was wondering if UIC can, if we use school email, if there is something that it is, part of.
They may have,
like
but I actually did not investigate that.
Okay.
The reason why I chose this was just to show a different vendor. They may or may not have free usage tiers. I don't know if DigitalOcean has it, but certainly AWS has it for students. I mean, not just for students, for any first-time user for a year, you get a lot of things for free. Okay. Trying to find the yeah, so sorry about that blocker here. Let me paste it. Test this device, that's fine. Verify. Okay, so typically AWS interface looks a little bit more complicated, okay, but this one is pretty simple, and we'll see how to start a simple basically rent a machine here. Okay, so for that, let's go to create, and we'll create, they call it droplets, but basically we'll rent a machine. So let's pick some, so they specify operating system. You can pick, so we'll pick one of the operating systems that's popular for web servers. Mostly it's Ubuntu. It's a Linux variant. Typically you will not see Mac OS or Windows. Windows you will see certainly, but not much of Mac OS. But we'll use Ubuntu, and we'll choose a plan. For us, we just need to try something out. So we'll choose a basic and some $5 per month machine. And they also let you choose something which is closer to wherever you're working, maybe your clients are, or whoever consumes your machine learning model. Let's just pick something, New York. And then there is this part where you can do, you want to log into this machine, right? So how do you log in? We'll actually just log in for now using the password. Okay. Wow, it needs more stuff. Okay, so actually you can probably see the password. It's something $123. Okay, so let's say finalize one droplet. No need to add any tags. And if you want to do backup, so this is what I was saying about managed services. You can actually, for us to, they're actually giving a service where they'll back up the system once a week for at least 4 weeks, so at most 4 weeks. So did I forget to choose something? Okay, password is not correct. Must contain one number. Oh my God. Cannot end in a number or special character. Okay, let's add a. Must contain one uppercase. Let's put S in the front. I will not remember this, so let me copy this. Oops. Okay, so now at least it has everything. No, must contain one uppercase. Oh my God. Okay. Okay, so anyway, so we created a, and that's it. And then you create droplet, and it's creating something. So this is the, it gave automatically it gave some string here. And it's working on creating that machine. Okay, so once the machine is ready, we can actually log into that machine. So let's Okay, so now it's your screen. So let's actually click on that machine. So now you can see, I mean, so not all interfaces will be similar. So why do we choose Ubuntu? Can we choose others? Certainly, you can choose any other. So they are actually very similar to each other. I would say there'll be a little bit variation in the commands if you use a non-Ubuntu or non-Debian style OS. But I think all of them are pretty much the same. In fact, Ubuntu is probably not the choice for servers. If you really in professional companies, folks generally use CentOS or whatever, Red Hat Enterprise Linux or Debian to serve. Or actually, Amazon has its own variants, names that you can use, okay, that are tuned for Amazon, for example. So actually, so this is what I was saying. So this is the IP address 104 something something. So we can copy this and let's actually try to log into it. So let's actually go here. So this is a terminal. So the way we log in is do SSH, and I think it's probably root at this IP address. Okay, and let's try if it works. So let's see. Yes. Oh yeah, it works. So now I need to retrieve that password that I said earlier. Copy, and I'm just going to paste it here. Enter. So okay, so we have actually logged in. So we gave the password here, and here's some introductory text about what is this machine about. It's basically running some Ubuntu, some version, and some information like, hey, this machine has 24 gigs of space. That's not much. This is this IP address. Okay, that one we used, and things like that, how much memory is being used and things like that. Okay, so that's great. We have logged in. Now, I think what I want to do is keep referring to the notes so that I follow the structure. So what we'll do is go back to the notes, and here we'll just go back to here and let's go back to the main, the original URL, which is available on yeah, we created a virtual machine. You can say this is a virtual machine, actually. Yeah, this is just from our perspective, it's a machine rented from these guys, right? So this thing is actually a virtual machine in terms of technology. But from our perspective, whether it's virtual machine or whether it's a real computer sitting in the warehouse or sitting on the company side is immaterial. Okay, but in reality, it's actually a virtual machine because on the same hardware, they will run multiple machines. Okay, but we don't need to know that. Yes, Microsoft Azure has something similar. And in fact, next several lectures, we're going to use Amazon and Google. And so you'll see how we'll keep on using these types of machines. For today, we just want to get acquainted with, hey, here's forget about all the other complexities. Here's one way to get to a machine, and let's try to do something inside the machine. Okay, but we will do something with Google and Amazon as well. We can also try Azure in the next session, for example. Okay. So for our perspective, it may be a virtual machine or an actual physical computer that they're renting to us. It's actually not physical because clearly you can see the moment I asked for a machine, they immediately gave it to me. So it's not probably physical, but yeah, it's a machine that we can use. Yeah. So now coming back to here, the link that we have in the for the course notes, let's click on B. Okay. So lecture B. Okay. There's again text as well. So what we'll try to do now is do two things. Okay. What's the purpose? Remember, our purpose and goal is to serve a machine learning model. But for that, we need to get our server ready. Okay. And this is what I meant by a lot of effort needed for DevOps. Okay. And the first thing we'll do is create a non-root user. Okay. So if you see on the on this terminal here, you can see at the bottom, it says root at the rate of this machine name, and then some tilde, and then the hash here, right? So let me clear this text, and you can see at the top as well. This is root at the rate of something. Okay. Root user is like a super user. Okay, they can totally delete the system and delete anything and everything on the system. It's not something that we would want to be always in. So what we can do is add user and give some name. So I said add user Teja, and okay, I'm giving a password. Okay, it's asking for password. It's basically setting up an account, just like you can create a new account on your Windows machine or a Mac machine. It's the same thing. Okay, so I'm not entering any of these information because it's not really, it's optional. So now we've created a new user. Okay, so what we'll do next is what we'll do is allow this user to run the super user commands, like an administrator command on Windows. Okay, so what we'll do for that is run the following. What we'll do is basically we're adding this user to the group of the super users. Okay, and the way you do it for at least Ubuntu system, and this is where things change slightly between systems. So basically what I did is this user Teja, I've added it to the users in the group sudo. Okay, so now I can run sudo commands as user Teja. Right now I'm still the root user. I'm logged in as the root user. Okay, so those were the initial steps. And to check that you have, what is it called? Super user access, you can do switch user. And by the way, this part is optional, switch user. Teja. So now I have become the Teja user because you can see it's my name at the machine name, and then I can do sudo, some command. ls is like a dir command in Windows. It's like just to list the entries, list the files in a directory basically. So I want to see a directory, let's say /root/. This directory generally is not viewable by a regular user. So since I made this user Teja a sudo as in like a super user, ideally I should be able to see this folder once I enter my password, and it says, hey, there's something there, it's called snap. Doesn't matter. So it seems that I have been, so I've created this user Teja who is also a super user, okay, or an administrator basically. Okay. Once we have that, then what we're going to do is install what is called an SSH server. Okay, and the way you do it is it's a standard command, so there's not so much for us to understand here. It's just going to install something, and it's very similar to us, downloading some executable and installing on Windows or Mac, right? Or going to an app store and installing it. So it's very similar to that. So here it says that it's actually already installed, so that's great. Next, what we'll do is the following. We'll actually create a directory here called .ssh. Okay, and what we will try to do is, so what did we do here? What we did in this guy's directory, home directory, is we created a folder called .ssh. Okay, what we'll try to do is put our public key in this folder so that we can access this log into this machine without using passwords. So what do I mean by that? Let's take a step back and let's actually go to let's actually forget about this untitled. Let's go here and create a new terminal. Okay, and let me actually go to my directory. Okay, so if you see, what is this? This is my local machine. Okay, it's my local machine. It's a ThinkPad. So this is my local machine. So if I this machine also has a this in my local machine, what I'm going to do is also create a .ssh folder, or it already exists. So let's go to .ssh, and yeah, so I'm in this folder .sh. What I'm going to do is the following, okay? And this is a key concept that you'll see whenever working with servers, is the idea of securely logging into the server. Okay, so that's enabled by this SSH protocol. So for this, what we'll try to do is create a couple of files. They are like a lock and a key file. The key file, or actually a lock and a key file, but let's forget about the lock and key analogy. Let's talk about a public file and a private file. Okay, the public file, I'm gonna put it on the server. Okay, so this is a server. I'm in a user called Teja. I'm gonna put that public file into the server that I'm gonna create now, and the private file will be with me. And using those two, I'm gonna log into the server in a very, without passwords. Okay, and why we're trying to get rid of passwords is because if it's, if password logging is, so if people can log in using passwords, then folks, hackers can try to brute force logging into the system by trying out all sorts of passwords. Okay, and we want to not do that. Okay, and this is just to show an example of there's so much thinking that needs to be done beyond me just having a model put on a server, right? So let me do that right now. So let's go to .ssh folder, and as I said, I want to put a file here. So let me create that file here. It's called authorized keys. So don't worry about how okay. So what were the commands I did? Vim is a text editor. Okay, because I only have this command line on the server. There's a text editor already on the server. I'm using that to create a file called authorized keys. This file will contain my public, not file, but some public information. Okay, so I need to add something here. What will I add? I'll do this following command: ssh minus key gen. Okay, and I'll say enter. Okay, I'll say, hey, what file do you want to create? What is this public and private file that you want to create? Let me say, hey, it's in this folder, Teja /.ssh. This is the default location. Let me call it, DigitalOcean server. Okay. Should I do this? Okay, let me not do this. Let me just call it ID RSA as a default says. If I could have pressed just enter. And just press enter. Okay, and passphrase, you can give a passphrase if you want extra security. I'm not doing anything, press enter. Okay, passphrase, no passphrase, press enter. Okay, so what I did is just run this command and press enter, enter, enter. Okay, it'll create those two files I was talking about, a public file and a private file. That you can see by typing ls. Is this the same as dir, as I was saying? There's an IDS, so ID underscore RSA. That's a default name that it gave, and then ID RSA dot public. Okay, the .pub file. Now this is the file that I want to put it on the server. Okay, so let me do, let me look at what the file is. It's just, these are all text files. So let me do less. So let me see the file that you can see by just typing less space the file name. Okay. By the way, I know I'm introducing a couple of extra commands, but they are not central to anything. There's going to be a recording of this anyway. So if you want to look at it offline of what was the specific command I used, it would be great to look at the recording. Okay. And also you can look at the notes which explicitly say this. So this is the text that's present in this file. I'm just going to copy this text, copy, and I'm going to paste it in this file. Okay. But what is this file? This is the authorized keys that I opened in the server. Okay. Once I paste it, the command to exit the text editor in Vim is escape shift : right and quit. Okay, shift : right and quit gave you this. If you can see the last line, it says : WQ. Okay, that's the way to quit the file. Okay, I've quit the file. If I want to open the file, it's Vim file name. Okay, you can see that this is the file name. This is the file. It has some text here. And if I want to again quit the file, shift sorry, shift colon WQ. Okay, exit. Okay, that's great. So we have this file, and let me see what file do we have here. Authorized key. There's there is some permissions issue, just like, for example, in Windows, you can make files read-only or hidden and so on. So I'm going to make it like something like read-only. Okay. So now what I can do is go back to my machine. Look, this is my local machine, as I said. This is Teja at T-Thing. Let me clear all this. Okay. Now, what have I accomplished in the past 2 minutes? I said I'm going to create two files, a public file and a private file. The private file is whatever it is. It's here. It's called IDRSA. Let's not worry about it. What I did is somehow the public file, I looked at its content. It was some messy, string of, like ABCs and so on. I just copied that into the server. Okay. And why do I know this is a server? I can see @ something NYC1 CBCPU and all that. And why is this a local machine? You can see this is my local machine. I know this. Okay. So with this, what I can do is do the following: SSH Teja @ what was the IP address? Let's look at the IP address here. This is the IP address 104.131.125, whatever. Let's go to my local machine, and I want to log in to this remote machine. Okay, so I can do that. Remember, I did the same SSH, but at root at this IP address earlier. So let me press SSH Teja at this. Like if I press enter, it should ideally log in. So see, it logged in without asking for my password. Right. So that is what we accomplished. And as I said, the reason for doing this is that we want to avoid everybody else trying to brute force and guess our password and log into our machine. Okay. You don't want to do that. You don't want that to happen. So let me pause here for a second and see if there is any question, or if folks are thinking this is too complicated.
See, is Telnet open between these two systems?
Okay, so the question is about whether Telnet is open between these two systems. No, Telnet is a protocol very similar to SSH. So Telnet, so we are not going to worry about Telnet, and Telnet is probably not open. Okay.
Oh, okay, all right, fair enough. Because you copied the file manually. I was thinking I could FTP it over there, or can I do something to get the file over?
You can.
Ah,
Yeah,
okay,
certainly.
right.
Yeah. So actually, SSH itself has a copy command, I think. Where is this?
Yeah, okay.
I forget the. Sorry, I've logged in here, but SSH minus. Okay, I don't know exactly the command, but you can actually copy without copy pasting like this. I agree with you. So there are many ways to achieve the same thing. Okay.
Yeah, fair enough.
Okay, so still, okay, what we have not done is, if you do, for example, I'm here. If I do Teja, it's going to use SSH protocol. Okay, but if I do root, it's still asking for my password, and if I give the password, it'll log in. Okay, we don't want that. Okay. So what we'll do next is, since we're on the server, we're going to disable password-based login. Okay, and that refers to this part of the. So what we've done, just to look at the nodes, we have installed. So we tried this. It said it's already installed. That's great. We created, on a local machine, we did these steps. Okay, we actually looked at the thing and we copied it onto the. So we did these steps. Okay, basically we copied that public key file onto the server specific location .ssh in Teja's local directory .ssh directory. We just created a file like that. Okay. Now what we'll do is the last step to really secure our server is, I mean, this is a minimal thing that you would do to completely secure off your server. Then, you can be pretty confident that, nobody is going to log into your machine, is to edit a file. Okay. And that file is something called config file. Okay. It's basically in some location, and it's a config file. It has a lot of configuration options, but we'll just try to change a couple of things. Okay. Port, let's not worry about port. We'll just change the root user cannot log in. Okay. At least, so that, you can't try, SSH root at this IP address and log in. Okay. That's a security risk to let root users log in directly. So we'll set it to no. And say, hey, and say, second thing we'll say is that password authentication is not possible. Okay, so you cannot log into this machine by typing out a password. If we disable this, we will still work because we have just copied our public key file onto that side. Let's not worry about the port and this extra stuff. This is just, it's not important. Okay, so let's do that editing. Okay. So how do we edit that? Sudo vim /etc /ssh /config. Okay, so vim again is the same thing, same editor. So let me just scroll down. I'm just going to do down arrow to go down, and it says here, you can see it's highlighted permit root login. Okay, so right now we are not in the editing mode, so I'll press I to get into the editing mode, and that creates this insert at the bottom. If I press escape, I'm not in the editing mode. If I press I, I'm in the editing mode. Okay, what I'll do is I'll add a hash in the front. Okay, that comments out that line. So comments you must have seen in R. You can add comments in R. Similarly, in this text file, we can add comment out some part by just adding a hash symbol, okay, or the number symbol. And it says public key authentication. You don't have to remove this hash because it's already by default yes. And there's a password authentication, which is yes. We will change this to no. Okay, and that's it. So escape to get out of the editing mode, Shift::WQ, and we have edited it. Okay, so I know I showed it a little bit quickly here, but I would suggest look at this part of the recording again if you want, if you think it's necessary. Okay, so now we have edited the config. What we will do is also restart the SSH server. Okay, so that can be done by the following command. By the way, these commands are not always transferable. I think somebody earlier asked whether we can switch from, why did we choose Ubuntu, Anupriya, right? So Ubuntu and Debian, I think these commands will work. I don't know if systemd is installed in CentOS. I actually don't know. So they may have a slightly different command, okay? Okay, so that's it. And now we've restarted. Now to check that root cannot log in, let's go back to our local machine. So I just changed the tab. And now remember we executed this and it said, hey, give me a password and I'll let you log in. Okay. Now we'll just do an up arrow to get to the same command and press enter. Okay. It says permission denied. Okay. Hey, you cannot log in because first of all, we don't let you log in with passwords, and you don't have your public key with us. Okay. So that's great. We have pretty much secured the system. At this point, it's mostly secure, I would say. Except there's one last thing you can see on the notes. If you go back to the notes, is that you can actually explicitly add a firewall which only lets a specific, which only lets anybody to connect only on one port. Okay, so what do I mean by that? Think of your computer as having ports. Okay, just like a shipyard, right? Ships can dock at the ports. So a computer has a lot of ports. They are numbered from 1 to actually like 100,000 or something, or actually, yeah, a little less than that. So when you're talking about ships, think of your computer as the shipyard, or a shipyard, and ports as these numbered locations where external things can come in. Okay, so right now on our server, the only external thing that should come in is my SSH based access to the terminal. Okay, and that comes in via port number 22. Okay, this is just that's what they decided as a port, and so it will always come from there. Okay, so what we can do is install a firewall and only allow port. Okay, only allow this port, and so this firewall will block everything else except for this port from coming in. Okay, and the next step is just saying enable this firewall and show me the status of this firewall. Okay, so let's just do these 4 steps now. Sudo.
Professor, we are building this firewall in the virtual machine that we rented. Yeah.
Yes, exactly. So we want the firewall in the virtual machine. So this pretty much seals the server, okay? And if people say, hey, why are you renting a machine on the cloud? Do you even know if it's secure against hackers? This is pretty much, what we did, like disabling password-based access and setting up this firewall pretty much prevents anybody from getting in, okay? Unless there's a big vulnerability in SSH itself, which is a big news in the world, okay? It will become a big news in the world if it happens. Yeah. So that's what we're doing. We're setting up a firewall on the machine in the cloud. Yeah. So sudo, sorry, not system, but apt install ufw. Okay, so it says, hey, USW is already installed. So great, that's great. So next, what we should do is allow a port number. Okay, sudo ufw allow. Actually, I can type SSH here, or I can just say 22. It's the same thing. So let me type actually 22. It's better. Okay, that's great. It says rule updated. I'm allowing this port, and I can do sudo ufw status verbose. Okay, it says, hey, it's inactive. The firewall is not active. Let's enable it. Sudo ufw enable. It says, hey, if you're going to start this firewall, if you're connected and it's not the right port, we're going to kick you off. Okay, so it says, proceed with operation. It may disrupt existing connections. You can say, hey, yes, because we did connect via port 22, so that should be safe. Okay, so firewall is active and it'll always start whenever the system is restarted. That's fine. It's already active now. So now let's clear all this. Let's look at its status. It says, hey, firewall is active. Some logging is on. It will deny everybody from coming in except anybody who comes in with port 22. And port 22, there's only one thing listening on port 22, which is the SSH server. Okay, so we have kind of any other port, including the web server port like 80 or 8080, we have kind of turned it off. Okay, and these other things, let's not worry about it. So this pretty much makes our server secure. Okay, I mean, there's a lot more things that can be done, but this is the minimum. Okay, now with that, let's actually see if we have time to get Python installed. What I wanted to get to today was not so much about deploying the machine learning model. I know we are a little bit slow. At least I'm a little bit slow. What I wanted to get to was at least get Python set up there so that next time in the first part of the class, I can deploy our model. Okay, and the model will be pretty much ready-made. I will pick up something so that we can do it next time. So let me get started with Python over there. Okay, so you can see there are many ways to get Python on the server system. So remember, everything we're doing on the server system. So local machine, don't worry about installing software, don't worry about conflicts, don't worry about all that. So on the remote machine or on the machine that we rented, we can just do this wget. So this is actually that, remember Anaconda that somebody was mentioning earlier. So wget is a way to like download something. Okay, if you know the URL, this is, so the file ends with .sh. Just think of it as a .exe file or something. Wget just gets you that file. Okay, so let's actually copy this and get that file on the remote machine. So remember, we are the remote machine. Since we are in .ssh folder, let's exit from there. Okay, now so I pasted that wget command here. Okay, in the remote machine, in just my home folder. If I press enter, it's just downloaded it. Okay, super quick. Next, that file is here. What we want to do is install Python. Okay, and installing Python is as simple as these two commands: chmod +x miniconda. So what is this command doing? It's just changing the mode of this file. Okay, this file is actually not, it's actually an executable. It's an exe file. So let's change the +x means make it executable. In the sense, we know it's executable. Right now, it's not allowed to execute. We'll change it to make it executable. Okay, let's do that. And then / the file name. Okay, / is generally even in DOS. If folks who have actually seen DOS long time ago, this is how you would execute a file. So / that will, and press enter. So it says, hey, Miniconda, in order to continue installation, press enter and all that stuff. So let's press enter. Bunch of agreement license. Do you accept the terms of license? Let's say yes. And then it says, we're going to install it here. Okay, this is my root, this is my home folder, home/Teja, that's my home folder. In that, we'll create a folder called Miniconda3, and we'll just install everything there. Okay, so that way, this installation is all within that just one folder. So maybe tomorrow or day after tomorrow, you're like, hey, I don't like this installation of Python. Just delete that folder, you're done. You know, everything else in the system is not touched. Okay, so let's press enter. It will install it. Okay, it will install the some version of Python. I think it's going to install Python version 3. Okay, there are some versions of Python, just like Windows 10 versus Windows 7 and all that. Yeah. In this moment, I want to check if folks are still with me or finding this complicated.
Yeah, you bring me fond memories of when I started coding in Unix.
Yeah, I mean, so this is just one-time setup. Okay, all I'm trying to do is get you set up so that you won't have to do it, you know, again and again. You just need to run Jupyter on this side, on this machine, and you can actually, you know, continue to use Python environment without doing anything on your local machine. Okay.
Hi, Professor Teja. Is there another use that used data ocean or something like that? But is
Yeah,
there
this is
other
DigitalOcean.
DigitalOcean? Yeah. So is there like other things that we can use to build
Yes.
machines like that?
Yes.
I know
I
this
would
is an
suggest if you
example,
don't
but
want
yeah.
to, if you should use AWS. I would say if you
Okay,
want to
AWS.
really
Okay.
do it, because
Okay.
in lecture 2 to lecture maybe even the last lecture, or maybe not last lecture, like a bunch of lectures, 6 of the lectures will use AWS.
Okay. Okay.
So you can get started getting a feel of it, but next lecture I will slowly start using AWS, and I'll show you how to interface how to start a machine on AWS. Yeah.
Okay. So will we be doing the same thing on AWS, or is it just like this lecture example?
Yeah, I mean, so I just didn't want to use the same thing for, just to show variety. I use this. Once you have the IP address, it doesn't matter whether it's from AWS or somewhere else. Okay. So so remember we created a droplet and we got this IP address, right?
Yeah.
From that moment onwards, when we went to our local machine and said, hey, can we do SSH root at that IP address? From that point onwards, it doesn't matter whether it's AWS or in somebody else. We have already got a computer. Okay.
Oh,
It's
okay.
all the same.
Okay. Awesome. Thank you.
But AWS or Google Cloud, any of them will be good choices. Yeah.
Okay. Thank you.
So, Professor, to add to that question, so once we take the AWS, is it like the same set of instructions to do our Jupyter notebook there, or would it be different?
Yes, it's the same instructions, exactly same. That's what I said.
Okay.
So the moment you get an IP address, you are pretty much set. Only there's a couple of extra steps for AWS, which is that they don't let you give a password first and then change it to passwordless access. They ask you to download some what is called a PEM file and work with that. Okay, so there's a little bit of a change. Maybe I can send all of you a link to how to do that extra step. Okay.
Yeah, sure.
That's just one extra step to get access to the machine. Once you get access to the machine, everything else is the same. The way we set up .ssh stuff, the way we did a firewall, for example, and the way we're installing, Python, it's all the same, exactly the same.
Okay.
Yeah.
So, Professor, your recommendation before next class is to do through DigitalOcean or through AWS? If we were to try all this.
I think you should try whatever you think is the useful thing. So I would suggest, if you don't want to explore another vendor, I would suggest stick with AWS or Google Cloud, okay? Because we will be using them anyway for about 4 lectures. So if you don't want to have too many you don't want to try out too many services, just stick with AWS or Google Cloud. Okay?
Is this all a paid subscription?
So on AWS and Google, yeah, all these are paid, but it's charged per, it's like 1 cent per hour. Okay, so for this session it would have charged me 1 cent. Okay. DigitalOcean. On AWS side, they actually let you get a machine for free. Okay, they will not charge you anything. But when you create an account, I think you still have to enter your credit card information, if I recall correctly. Okay. But they will not charge you for the free tire machine. So you can look up free tire. So it's exactly the same. Okay, instead of droplet, there'll be a choice for, hey, do you want, which machine do you want? In that, they'll explicitly say they're free. Okay, and if you pick only that one, you will not be charged. Okay. On AWS. Same thing on Google Cloud. There'll be a free version, free instance, or what do you call it, free virtual machine. or a free computer, you can just pick that one and they'll all work. Okay. So when you create an account at AWS or Google, and we'll actually do that. So I think we're jumping 2 steps ahead. Today, I just wanted to show you a different vendor because otherwise everybody only knows AWS and the world, there are many other vendors who do the same thing, right? In fact, for small businesses, things like DigitalOcean or some other vendors are more cost efficient than AWS. Okay, it's just cost works out that way. Yeah, we'll do AWS next week. So if you want to try something out, look, I'll send out an AWS tutorial how to get started with that free machine. And then once you get the IP address for the free machine, it's the same steps. Okay.
That'll be great, Professor. Thank you.
So I think what I've done so far.
Questions to you. I don't mind staying back after class if you want to, if you're available.
Yeah. So I will be. So okay. So that's a great point. Thanks for pointing it out. So our class ends in a minute. So I'm going to wrap up for where we. So I just conclude where we are, and then the Zoom link will be open. I'll stop the recording and we can continue to chat. Okay. Continue to. It would be great for the first 5 minutes or 10 minutes if everybody's here so that they can introduce themselves to other folks in the class. If certainly don't be compelled to be here, but you can certainly, that's what we'll do. In the last 1 minute, what we did so far is just install Python on the remote machine. Okay, how do I know that? So I can do clear. I can type. Maybe I need to do. Okay, this is one extra command only to just so that the path is updated. Path for Python is updated. Okay, so you can see now actually something changed. This is it says base here, which clearly means that which actually means that Python is installed. So I can type Python and press enter. It'll say, hey, Python 3.8. It's by Anaconda. Okay, and you can type print whatever. So this is great. Python is installed. Now the only thing missing is we want something called Jupyter. By the way, Jupyter is just a package within Python, so it's easy to install. So we'll do it next time. Okay. Once we have gotten Python, everything else will be in Python. So hopefully the command line stuff that you saw today is just one-time activity that you have to do. You don't have to do it. You have to do it if you want to do self-hosted, single web server-based machine learning, model deployment. So, and next time we'll see many other options. So that's it for this class. Thank you so much for your attention. So I'll stop recording now. And